CNC machine tools are precision equipment crucial to modern manufacturing, and their stable operation directly impacts production efficiency and product quality. Mastering effective fault diagnosis skills is essential for quickly restoring production and minimizing losses. Welcome to the mini-lecture on intelligent equipment fault diagnosis and maintenance. First, consider the reasons that lead to frequent faults in machine tools. Today, we will delve into the core methods and practical techniques for diagnosing CNC machine tool faults. Faults are more common during the early use of machine tools, often due to operators and maintenance personnel being unfamiliar with the equipment. Software faults can arise from issues with detection switches, hydraulic systems, startup systems, electrical devices, and mechanical components. Previously, we have discussed the classification of CNC machine tool faults. Now, let's explore the basic process of fault diagnosis. Successful fault diagnosis follows a scientific process, which includes 1. Recording fault symptoms. Detail the environment, symptoms, alarm messages, and operating steps when the fault occurs. This is the first step in diagnosis. 2. Preliminary analysis. Based on recorded symptoms and experience, make an initial judgment on the potential cause of the fault, such as electrical, mechanical, or control software issues. 3. Detailed inspection. Use diagnostic tools such as multimeters, oscilloscopes, and specialized diagnostic software to perform an in-depth examination of the suspected fault area. 4. Fault confirmation. Verify the fault by testing, such as replacing components or adjusting parameters, to confirm if the fault has been resolved. 5. Summarization and documentation. After resolving the fault, organize the case including the cause, handling process, and lessons learned to provide references for similar future faults. These 5 steps are not only the logic of CNC machine tool fault diagnosis, but also represent the diagnostic approach for intelligent equipment. Next, we will introduce several commonly used methods for diagnosing CNC machine tool faults in detail. 1. Observation. Assess the machine's operating status, appearance, and sounds to make a preliminary judgment about the type and possible cause of the fault. For example, check for signs of water or oil leaks and listen for unusual noises. 2. Listening. Use a stethoscope or your ears to listen to the sounds generated during machine operation and determine if there are any abnormal noises. Abnormal sounds are often related to mechanical or electrical faults. 3. Touch. By touching the machine's components, motors, and circuit boards, check if their temperature and vibrations are normal. For instance, an overheating motor may indicate an internal fault. 4. Measurement. Use measurement tools such as multimeters and oscilloscopes to measure electrical and mechanical parameters of the machine to ensure they meet required specifications. For example, measure the motor's resistance, voltage, and current to verify its proper operation. 5. Replacement. If the faulty component cannot be identified, use the replacement method. Replace the suspected faulty component with a new or known good one and observe if the machine operates normally. If the machine returns to normal operation, the replaced component was faulty. 6. Logical analysis. Analyze the fault's cause and possible impact based on the machine's working principles and control logic. Logical analysis can help narrow down the fault search area and improve diagnostic efficiency. Finally, let's review some practical tips. Basic repair methods are fundamental to fault diagnosis, but mastering some diagnostic techniques can quickly pinpoint the fault's cause. 1. Pay attention to alarm information. Alarm codes provided by the CNC system are valuable clues for diagnosis. Consult the operation manual or manufacturer's documentation to quickly locate the problem. 2. Consider environmental factors. Take into account the impact of temperature, humidity, dust, and other environmental factors on the equipment, as they can often be the cause of latent faults. 3. Regular maintenance. Prevention is better than cure. Regular cleaning, lubrication, inspection, and data backup can effectively reduce the occurrence of faults. 4. Knowledge update. CNC technology evolves rapidly. Continuously learn from the latest repair manuals, technical documents, and training to enhance your skills. Through this lesson, I hope to ignite your interest in fault diagnosis technology, encourage you to continuously gain experience and practice, and enable you to handle faults calmly and accurately, thereby reducing repair costs and effectively ensuring and enhancing production and economic benefits for enterprises. This concludes today's lesson. Please review and consolidate the material after class and complete the following exercises. See you in the next session.